We've already talked about exponential growth and decay, right? And just as a reminder, let me tell you what those formulas, remind you what those formulas are again. They are f of x equals ae to the power of k times t. Sorry, got my pen stuck there. K times t, right, for exponential growth. And for exponential decay, we're looking at f of x equals ae to the power of negative kt. Remember that k is a constant, t is time, and the problem will give you time. And then you're looking at e, which is a constant as well, right? So now we're going to talk about something called logistic growth. Logistic growth is this idea that when you reach a certain amount, you can't keep growing. So let's say that I have a pond. Just cope with my drawing for a second, okay? And in this pond, I have fishies, all right? And I have all of these little fishies, if I can draw them, maybe. Right, I have all these little fishies. And these fishies were put here by man, okay? And up to a point, they're going to end up reproducing, and they're going to make lots of new fishies, okay? You're going to end up making lots of new fishies, okay? And I know my drawing's terrible, but up to a point, you're going to run out of food, right? At first, there's plants and things like that, and then at some point, you're going to run out of resources. And so what will happen is your graph will look like this, okay? When I'm graphing a logistic growth equation, my x-axis is time. And my y-axis is the number of things, right? Whether that's fish or rabbits or eggs or whatever. And what's going to happen is that at the beginning, there's not a whole lot going on. And then there's going to be some level of growth. But then at some point, there's going to be some limit and it's going to level off, right? You're going to reach a maximum. And that's what happens with things like man-made ponds, where you can't continue to grow because the fish will just start dying off, okay? So for this type of problem, we have an equation called a logistic growth equation, okay? And we're going to use E in this equation. And yes, this is an equation that you're going to need for your test. Okay, and this is something I expect you to know. Logistic growth, right? Logistic growth equation looks like this. A function, f of t, is equal to some constant, c, over 1 plus a e to the power of kt. So that should look familiar to you, okay? That should look familiar to you. Now, I'm going to make a couple of adjustments here, right? You should be able to recognize this. Right? You've seen this before. Right? And what I want to note here is that the letter K they use actually in this particular equation, they use as negative B. And what negative B is that B must be less than 1, okay? And it's the logistic growth, kind of a constant for that, right? So your logistic growth equation actually looks like this when you're talking about it. So you're actually going to go 1 plus a e to the negative b t, where b is between 0 and 1. And so what that does is that particular constant kind of holds your population down so that it doesn't explode, right? So that's an exponential problem there. So let's look at a problem. A lot of times these are sort of population problems, so let's look at some. Okay. Let's look at population of a city, all right? And so I'm using the example out of the book. Population of Phoenix, Arizona in millions can be modeled using this function. So let's use this function, f of t equals 2.066 over 1 plus ae to the power of negative, I'm sorry, I messed that up. They actually give me a value here. 1 plus 1.66 times e to the power of 0.048 t. And what the problem gives us is it tells us that it looks at t as the number of years since 1980. Okay, and so then it's going to ask you for a graph, and you'll have to sketch it. Okay, but what we're looking for is we want to look for a couple of things, right? What is the maximum population? What is the maximum population? And the maximum population is going to be 2.066 million people. And how do I know that? Because when I graph this equation, okay, and you'll graph it on your calculator, and we'll do that together in class. When you graph this, you use the number of years, okay, as your x-axis, and then you're going to use your population as your y. And when you graph it, what you'll find is that it looks like this. And it'll bottom out, or it will max out at about 2.066. And the reason that it does that is because this denominator, right, is always going to be 1 plus something. And if the exponent is negative, then the highest that we can get when we talk about that is we're going to go towards the bottom ending up equal to 1. So your maximum is always going to be the top value. Okay, so now let's look at how to calculate. So let's look at the equation again. Oop, I don't want green, I want black. So f of t is equal to 2.066 over 1 plus 1.66 e to the negative 0.048 t, okay? And so what I want to do is I want to know when will the population reach 1.8 million. So where does this go? This 1.8 million is actually this f of t value. So what am I really doing here? I'm solving for t. And so you're going to do that the same way that you would solve any other kind of equation. I'm actually just going to use 1.8, and we can add the word million, right? But it's so much easier to calculate when I don't have to worry about that million part. So here's my equation. I want to solve for t. Okay, so what I'm going to do is I'm going to multiply both sides by this denominator here and then divide. So what I'm actually going to do is I'm actually moving this section here and moving this down here. Okay, so it's going to look like this. 1 plus 1.66 e negative 0.048 t equals 2.066 over 1.8. Okay, subtract 1 from both sides, so I'm going to get 1.66 e negative 0.048 t equals whatever that value is, divided by 1.8. So let me get that value for you. 2.06 divided by 1.8 is equal to 1.148. I'm going to subtract 1, right? I know I'm getting kind of close there. So 1.66 e to the power of 0.048 t is equal to 0.148. Divide both sides by 1.66. Makes it 0.0892. Ln both sides, right? So now we're talking about exponential equations. I'm going to ln both sides, so I'm going to end up with negative 0.048 t equals ln 0.0892. So t is ln 0.092 divided by negative 0.048. Okay, so let's do that. Ln 0.0892. I get a value on my calculator of negative 2.41. I'm going to divide that by negative 0.048. and I get 50.35. So this is years, time in years. So these are a lot of plug and chug type questions, right? So a lot of it you'll be given a formula and asked to solve, and we'll work on that together in class.